Okay, let's go ahead and start with chapter 3. And I am on the wrong section. Let me try again here. All right, chapter 3. Here we are, section 1. You're going to find that with this chapter, we're going to start getting into more and more into equations. All right, solving equations, talking about kind of not just the guess and check approach, or it's also called brute force, but we're going to talk about the actual conventions of solving equations, the inverse operations, like the procedures, the formal operations that we use to solve equations and getting into them like that. All right. So, all right. So what do we have here? So we got, so let's talk about the basics. That's what I have around part 1. So the basics. So an equation, what is an equation? All right. Equation is a number sentence stating that two quantities or two expressions perhaps are equal to each other. All right. All right. The blank of an equation, the solution of an equation is the value of a variable. I should, I don't know, like I don't always like calling it a variable because variables makes it sound like it could be anything, but it's really called an unknown. That makes, it's the value of the letter, more or less, the X, the Y, the N. It's the value of the variable that makes each side of the equation true. In other words, balanced. Okay, so like right here, circle the equations below that are equivalent to X equals 3. So if we put in 3 for X, does it come out true? Yeah, right there. That one works. That one's true. We put in 3 here. No, that's 4. 4 does not equal 6, so nope. All right, if we put a 3 in here, well, that's 9. Nope. We want that to equal 8. Right here, if we put a 3 in, that's 6. Well, that does not equal 3. Right here, if we do this, that one works. 3 plus 1 is 4. And right here, 3 plus 2 also equals 5. Okay, so there was 3 equivalent equations that had x equals 3. All right, and then usually in class when I do this, but we're doing this online. But as a group, read and answer the following. Jennifer has some video games, and then she bought 4 more. She bought 4 more games. Now she has 10 games. This situation can be described using the equation of x plus 4 equals 10. So what does x represent in this situation? Well, it says that Jennifer has some video games. Like like this is what she had before, and then she bought some more. So the x represents what she had before. So I'll put video games she already had, before she made some purchases. All right, now write 2 different equations that are equivalent to x plus 4 equals 10. So what that basically means is there's an infinite number of answers to this. There's lots and lots and lots of different answers that we can put in here. There's no end to the number of equations that we can write that are equivalent to x plus 4 because we know that x is 6, right? Just because 6 plus 4 is 10. So just write any equation where x is equal to 6, so we can do one example would be like x plus 7 equals 13 because 6 plus 7 is 13. Excuse me. And another one could be like x plus negative 10. I'm going to do a negative number in here, but because 6 plus negative 10, that's negative 4. See, we can put in 6 into that equation, and it is true. We can put 6 into that equation, and it is also true. So that is what we just did there. Okay, so focus of the lesson, let's get into this. So inverse operations is really what the focus is on here. So we got this thing called inverse operations. Inverse operations are opposite operations that undo each other, or in other words, cancel each other. For example, the inverse, the opposite of addition is subtraction. So the inverse operation, oops, I'm spelling that wrong. The inverse operation of addition is subtraction. And the inverse of division is multiplication. Those are some of the more common types of inverse operations. So we've got some examples here where where it says for the following equations, name the inverse operations needed to solve the solution or to find the solution. I don't know, I'm having a bad time with words here, whatever. All right, so you got right here. Now, so what you do is what you want to focus on is the letter side, okay? So we will focus on the letter side and notice multiplication's going on there. You got 6 times a number, 6 times x. So the inverse of that would be division. So we would divide by 6. Now, I'm not really interested in solving these. I'm just interested in naming and pointing out what the inverse operation is that we would use to solve it. Okay. So on this one right here, look at the letter side. Look at where the variable is, and that's plus 18. So we're adding 18. The inverse of adding 18 is going to be subtract. So we're going to subtract 18. Subtraction. All right, on the letter side here, we've got division going on, right? This is a division problem. A number divided by 12. That's division. So we're going to multiply by 12. Okay. And then right here, you've got, sorry, it's all pixelated there, but we've got, now we have addition. However, let's pay attention to that sign. So the sign of -3 is negative. So to undo a negative, we got to do a positive, even though there's a plus sign there. We really want to focus on adding 3. So we're going to add 3 to both sides. Okay, now this is an example right here where you have to clean it up a little bit. So like right here, these 2 negatives make a positive. So we really want to think of that as +4. So the inverse of +4 is going to be -4. So we're going to subtract 4. All right, and then on this one's tricky. All right, but what helps, I think, is to understand, and we've had this conversation, or at least I've talked about it in one of the videos, that when there's a letter, when there's just a variable, the default number that's in front of it is a 1. Now, this is negative t, so you can think of it as -1. All right, so now if you think about that, what's going on that side? Well, that's multiplication, right? That's -1, right? Think about that. That's -1 times t, right? -1 is being multiplied by t. I don't think I used x. -1 times t, right? So the inverse of multiplication is to divide. All right, so you can divide on this one. We're going to divide by -1 on both sides. Now let's actually do some inverse operations and actually start solving these problems. So on this first example, on example 1, we've got a number plus 23 is equal to -8. So we're going to focus in on this plus 23. So the inverse of 23 or plus 23 is -23. And then one really, really big rule of solving equations is to, whatever you do to one side of an equation, you do to the other. Okay, it's very important you follow that rule. It's called the property of equality. So those cancel each other out, right? But so really over here is going to be the end solution, which is going to be x equals -31. And then we can check it. -31 plus 23 does equal -8. Right there. All right. This next example right here, This next example, what we've got here is we've got some like terms that we can put together. Right here, -5 and 6 makes, that makes x, right? That makes x. I'm gonna rewrite it. You got, which is 1x, but I'm just gonna write x. All right, -9 equals -17. All right, and then now the inverse of -9 is going to be +9. So we're going to add 9 to both sides, and that should do it. So we got x equals -8. And we should be able to put that in for x over there. Okay, so -5 times -8, that's 40. 6 times -8, that's -48. All right, and then I'm going to write plus -9. You do that. Now right here, 40 plus -48, that's -8. -8 plus -9, that is actually -17. So that checks out. All right. Now, part two kind of goes in weird directions, this section here, but whatever. For this one, we got a little bit of geometry going on, and we're going to apply some algebra to figure out these geometry problems. So let's kind of get through some of these notes here. So this right here, what we have here is we got examples of complementary. Well, I've got two angles that are complementary. I should have showed, or I've got two angles that are supplementary. All right, and that's, I don't know why I didn't put one complementary and one supplementary, but whatever. All right, so supplementary angles are two angles that have a sum. That means they add up to 180 degrees. They add up to 180. All right, complementary angles are two angles that have a sum of 90, so exactly 90 degrees. All right, so right here we've got two angles, like right here we've got 138 plus x. So if you were to set up an equation for this, you can just go x plus 138 equals 180. That's what the equation, I think that's what we want to be able to do with these kind of geometry problems. And then we're going to take away 138 like that. And those cancel off. And then there it is. So x equals 42 degrees. Okay. It's important, like when you're doing geometry problems, especially like in an algebra textbook or a geometry textbook, very tempting to, especially if you have a protractor laying around, you might just take a protractor out. Like, oh, it's much easier if I just measure it, right? don't ever do that, because a lot of times the angles aren't drawn to scale. They might be a little bit off because they want you to focus on the actual algebra that is involved in solving it. Okay, so just keep that in mind. All right, so this one we're going to set up an equation. Y plus 77 equals 180. I should really, I don't know. That's all right. So we're going to take away 77 from both sides, and that should do it. You got y equals 103 degrees.